This video is about how to make the call when you're faced with a dot plot turned into a box and whisker plot. First of all, you want to draw yourself some lines up and down from the two medians and either draw a line between those line with arrows between those two medians, or you could even measure it with your ruler. I measure the distance between those two lines. Once you've done that, you want to draw a line up from the lowest quartile and the highest upper quartile, and again draw a line between those two quartiles, and we call this the overall visible spread, or OVS for short. What we need to do now is compare the distance between the medians and the OVS. So what I do is I translate the distance between the medians in red up to put it in line with the OVS. Now the rule is, if we can fit the difference between medians 3 times into the overall visible spread, then there's enough evidence to make the call. If it fits more than 3 times into the OVS, then it's what we call too close to call, and we don't know if there's an actual difference between male and female heights back in the population. This time, you can see here, it fits in 4 and even more than 4 times, therefore it is too close to call. I'll show you a couple more examples, and all of these examples are difficult to tell without actually drawing on the diagram or even using a ruler to measure these distances. Here's another example: right foot length by gender. By the way, I forgot to mention that this data comes from 100 samples for Year 4 to Year 13 students within New Zealand. Okay, can we make the call, or is it too close to call? Again, draw in those lines I talked about, the difference between medians, and draw in the OVS line. Transpose the difference between the medians to above the OVS line and compare. Can you fit that distance in 3 times exactly, which you could make the call, or 3 times or less, or is it more than 3 times, which it is in this case, therefore it is too close to call. And what I mean by too close to call, I'm saying it's too close to say whether males have longer right foot length than females back in the population, which the population, as I said, was Year 4 to Year 13 students in New Zealand. So we can't say for students in New Zealand whether males have larger right foot lengths or not. Here's another example. This is bag weight by gender, same population, and I've just, in this case, drawn 2 lines up from the medians. And there's such a small difference there, I can straight away see that it's going to be too close to call. To be able to make the call, the distance between those medians needs to be significant so that we can meet that equal to or more than a third rule between the difference between the medians and the overall visible spread. So I'm going to say here, the bag weight by gender is too close to call. Back in the population, or back in students within New Zealand, we can't say that males' bag weights are lighter than females. If I was to take it, and this is the excellence part or merit part, if I was to resample from the population, I could very well find the medians would swap around. That's showing you understand sampling variation. Here's another one, controversial. Memory by gender. What it looks as though is males have able to remember more things, whatever the scale is, I'm not sure, than females. Very possible, but let's do the statistics around it. We've collected a sample of 50 males and 50 females. We've plotted dot plots, converted those into box and whisker plots. Now we're sitting here trying to think, ooh, back in the population, I wonder if males do have a better memory. Well, as I've been saying, we need to draw in those lines from the medians, look at the difference between those medians, measure it if it's close, draw in the lowest quartile and the highest upper quartile, connect those, and we call that the OVS, transpose that difference between the medians, and check. Ooh, I think we can say that males have a better memory than females back in the population. And that's what you would say for achieved back in the population. Males have a better memory than females, according to the survey. And for excellence, merit and excellence, you would be needing to talk about resampling, what might happen with a different sample, what were the biases, could this apply to adults, could this apply to students in Australia, that kind of thinking. Right, another example here. This is, I've changed the population down now, and I've just looked at Year 11 students in New Zealand and compared their shoulder width between gender. Okay, can we make the call? Draw a line down from the medians. Well, the median for the males falls outside the upper quartile for the females. Therefore, we don't even need to worry about our OVS 1/3 rule. We can immediately say that the males tend to have a larger shoulder width than females for the population of Year 11s in New Zealand. I've just popped back a few slides here. I've looked at this right foot length between gender 1 already. Now notice the median for the males when it comes down. It looks as though that it might just pop outside the females' upper quartile, therefore saying, well, the male's right foot length is bigger than females. If it's at all ambiguous or close, you need to use the 1/3 rule. Okay, that's what it's there for. If it's definitely outside, like the earlier one, this one, then yep, go make the call. But if it's ambiguous, it's close, hard to tell, use the 1/3 rule. Here's the last example. We have right-handed people, left-handed people, and ambidextrous people. People who can write with left and right hand, or play golf with left-handed or right-handed, or whatever. The question here could be, what is the difference? And I've looked at their wrist circumference. The question here could be, what is the difference between left and right-handed people and their wrist circumference? Well, as I hope you can see, the medians are identical, therefore it's too close to call. Back in the population, people who are left-handed, people who are right-handed, there's no difference between their wrist circumference. What is interesting though is if I extend those median lines up and compare it with the median of ambidextrous people, and compare it with the OVS, i.e. the lowest quartile and the highest upper quartile, without even drawing those areas in, can you see the distance between the red lines is roughly 1/3 of the way across between the distance of the blue lines? I hope you can, because if I'm comparing right-handed people and their wrist circumference with ambidextrous people and their wrist circumference, I reckon I can say, back in the population of secondary school students in New Zealand, it's a fairly safe bet that ambidextrous people will have a larger wrist circumference. And I'll leave it to you to think about some of the evaluations you'll need to talk about in excellence for this one. I don't by the way, think you could make the call if you looked at the wrist circumference of left-handed people and ambidextrous people. I think that one would be too close to call as well, but do check it out for yourself.